Hi, welcome to New Tech YouTube channel. In this video, we are going to study and solve example on Kirchhoff's voltage law. Let's begin. The statement of Kirchhoff's voltage law, in short, we call it as KVL like this. The algebraic sum of the voltages around any closed path or loop is zero, where loop is closed path of a given circuit. In terms of mathematical equation written as summation of all voltages around any closed path is 0. In equation form, summation V is equal to 0, condition that given circuit or loop must have closed path. We have just studied statement of Kirchhoff's voltage law and its mathematical equation. Now let's study how to apply KVL to a given circuit with closed loop. Here closed loop indicated by yellow arrow with path labeled as A, B, C, D. The voltage source Vs having current I passes through resistor R1 gives voltage drop V1. Same current passes through resistor R2 and R3. We get additional voltage drops of V2 and V3 respectively. Using previously studied circuit diagram with closed path, now KVL equations represented as voltage source Vs minus voltage V1 minus voltage V2 minus voltage V3 equal to 0, represented by equation 1. In equation 1, Y voltages V1, V2 and V3 are having minus sign because with reference to circuit diagram, the current direction we marked voltage polarity plus minus across resistor R1, R2 and R3. In closed path tracing, voltages in a clockwise direction with second terminal is considered as a reference terminal. Now voltage Vs is equal to V1 plus V2 plus V3 represented in equation 2. With values of voltages, V1 is equal to current into resistor R1, V2 equal to current into resistor R2 and V3 is equal to current into resistor R3, obtained using Ohm's law as a voltage V is equal to current into resistance R individually. Using KVL, let's solve the following example. Example statement: find current I, voltage V1, V2 and V3 using following circuit. Given data as voltage source Vs is equal to 50 volt, resistor R1 is equal to 10 ohm, resistor R2 is equal to 15 ohm and resistor R3 is equal to 20 ohm respectively. Solution to a given circuit using KCL as voltage source Vs is equal to voltage V1 plus voltage V2 plus voltage V3 represented by equation 2. Substitute values of Vs, R1, R2 and R3 into equation 3 as 50 volt is equal to current I into 10 ohm plus 15 ohm plus 20 ohm into equation 2, where take a current I is common equal to 50 volt divided by 45 ohm, where after calculation we get a current I is equal to 1.11 ampere. Now find values of voltage V1, V2 and V3 as V1 is equal to current I into resistor R1. Substitute value of current I is equal to 1.11 ampere into resistor R1 is 10 ohm. We get a value as a 11.1 volt. Similarly, V2 is equal to current I into resistor R2. Substitute values of current I as 1.11 ampere and value of R2 as 15 ohm. We get a voltage V2 is equal to 16.65 volt. With voltage V3 is equal to current I into resistor R3. Substitute value of current I is 1.11 ampere and value of R3 is 20 ohm. We get a voltage V3 is equal to 22.2 volt. Now for check, add values of V1, V2, V3 we have just calculated, then we get its total value is equal to the value of a voltage source. From this, we conclude that we have verified the Kirchhoff's voltage law using example. In this video, we have studied example on Kirchhoff's voltage law. Thanks for watching my YouTube channel. Thank you.